Thank you, Dr. Nagraj and team, and I welcome all of you for our 23rd update. I think we will start the session with the very concept of why, how the world started thinking about the autoimmune disease. Prospectively, we all believe, and we are forced to believe as we start thinking about immune system, the immune system is designed for defense. When it is designed for defense, our thought process is subsequently it is never supposed to attack self. Because we don't expect our army to fight against self. It is supposed to defend even the people who fight against self. So that being the case, the concept of autoimmunity was very much in confusion, especially in the era of microbiology. If you remember, in 20s, 30s, 40s, where we were discovering a lot of microbes, we used to believe that every disease is caused by microbes, and subsequently we discovered that there is an immune system which is expected to fight against these microbes. And we are, at that point of time, were forced to believe, and every entire scientific community believed, that immune system will never attack self. The concept of never attack self was so strong because at that time we believed every disease is caused by microbes, and we also were not ready to believe beyond a concept that the nature can have a design in the system which can err in a wrong directions, because we believed that the nature is God and God doesn't make a mistake. I mean, that's a concept that will be there always at that time when the science was partially ruled by the religion. That's a point of time it was very tough for anyone to say that immune system can fight against self. And at that time, the Paul Ehrlich broke the feeling that yes, autoimmunity can occur, and he gave a term called horror autotoxicus, but still in the end of his lecture, he said that it is a pathological process, it is a process which is abnormal, and it's a pathogenic process, and it's rare. It doesn't happen very commonly as it can happen anytime. So the belief that even he proposed an autoimmunity, he continued to believe that immune system doesn't attack self. So then came the concept which literally started changing. Then Burnet proposed something what is called as clonal theory. What do we mean by clonal theory is immune system will have its repertoire to fight against different microbes. And it also has some of the epitope, that means some of the signals which can identify self. But in the process of selection, it will pick only things which are useful and delete something which is not useful or which is going to react against self. This is the theory which we still believe and we continue to believe, and this is one of the central theme for what we call as central tolerance, where immune system filter off the self-reacting cells and only allows something which has high affinity towards the external proteins. And then came the next concept proposed by Peter Medawar. See, the Medawar said that in the initial phase of the development, in the first few infancy time, body starts not responding and start identifying which one it to respond and which one it should not respond. We still believe the Medawar's concept is correct, and also we use this particular concept especially in the oral tolerance and various other mechanisms which we use. Here he proposed that the body figures out in the first few initial year of infancy or a growth that what are the proteins which it should respond, what are the protein it should tolerate. So the concept slowly moved from what we used to believe that there is nothing called a self-reaction, and from there could be a possible self-reactions, but the self-reaction is limited, filtered and trained and taught about why and when not to respond. Slowly the science progressed and we started identifying few of the autoantibodies. First among them was the discovery of both anti-nuclear antibody as well as rheumatoid factor. Started down at 1940, but We were not very sure they are antibodies or not. We called them as serum factors because we were still unsure about the immunoglobulins at that time being self-reactive. These serum factors were expected to stain the nucleus, also react with immunoglobulin proteins, and then we thought it could be rheumatoid factor as well as ANA, which was also further described by the description of LE cell phenomena, which of course now we have discontinued being used because we have more sophisticated thing. The LE cell phenomena, which is also a part and parcel of anti-nuclear antibodies, was also discovered. Slowly we moved on to define the subtypes of ANAs. There they discovered anti-dsDNA, extractable nuclear antigens, and various other factors. With the development of techniques like indirect immunofluorescence, ELISA, and various other techniques, the number of cells, number of autoantibodies gradually increased in its number. And of course, the discovery of cell culture, Hep2 cell lines, they all improvised the way we can look at these autoantibodies, their discoveries and detections. So, slowly we started working on the autoimmune disease. We started believing that yes, autoimmune disease exists, but with the belief that autoimmune disease is relatively rare, it is less common, not as much as we are expecting, and slowly we tried to associate some of the clinical manifestations like arthritis with rheumatoid factor, with connective tissue disease features with ANA, and several other autoantibody descriptions. The first of them is hypothyroid, where they could describe that anti-TPO, anti-TG, which could slowly destroy the thyroid and produce the several of the autoimmune thyroid diseases. So slowly over a period of time, we started realizing, yes, the autoimmune disease exists and the autoimmune disease is a possibility. Several constellation of symptoms were put together to give names and designations of several autoimmune disease. But the question comes is, how should I label a disease as autoimmune disease? When should I call a disease as an autoimmune disease? We had, if we recollect down when we were the undergraduates, there were a lot of diseases which used to be called as idiopathic, where the etiology is not known. We always used to joke it whether we are idiots or every science world is idiotic about not to know about this idiopathic disease. Most of these idiopathic diseases were slowly categorized into autoimmune disease or a genetically predisposed disease, and few of them are still in a question mark where we need to answer those questions. But when should I call a disease as an autoimmune disease? At least with reference to microbiology, we have Pasteur's postulates, where he clearly said that if you isolate a microorganism and demonstrate its association and producing at least similar or a closer features in an animal model, or elimination of those bacteria resolves the disease which it is manifesting, were two criteria based on which we can say that a given microbe is associated with the infection or infection described disease. When it came to autoimmune disease, we were very not unsure that right in 1993, Rose and Bona, which was modified version of Witt-Baski's criteria for to call it as autoimmune disease emerged. So here we use 3-4 different steps. One of them is a direct evidence, where I can demonstrate autoantibodies and show the association of autoantibody with the disease. We can definitely make it that it is autoimmune disease. The other one is a transfer. If I transfer the autoantibodies into the animal model and show it in the animal model, it produces some of the picture which are similar to what is described in autoimmune disease. That's another direct evidence where it can very clearly shows that yes, this is an autoantibody and this is possibly an autoimmune disease. And other indirect evidences are where you can show through a controlled laboratory studies. Controlled laboratory studies, what we meant is, it may not show the similar autoantibodies which is described in the humans. For example, we have a rheumatoid arthritis model. In the rheumatoid arthritis model, we have anticollagen and other autoantibodies, and those autoantibodies produces a picture which is similar to rheumatoid arthritis. We have never been able to produce a rheumatoid factor in few of the animals, and also transfusing rheumatoid factor into animal, we have never been able to replicate a disease similar to rheumatoid arthritis. So there is indirect evidence or animal models and others which can help us to describe and say that this could be an autoimmune disease. The last one is what we call as circumstantial evidence, and most of the autoimmune disease currently follows these particular criteria, because we are not able to show quite a good number of autoimmune disease in relation to this. In circumstantial evidences, the presence of autoantibodies or autoreactive cells. If you demonstrate an autoantibody, for example, anti-thyroperoxidase, if you demonstrate, probably if you can also show that the thyroperoxidase antibodies were sitting there in the thyroid and producing the things, it is a fair enough evidence to say that yes, that could be an autoimmune disease. And also strong genetic tendencies or association of those diseases with the autoimmune diseases, or improvement with immunosuppressive. Quite a good number of encephalopathy still falls in these categories. Give a trial of steroids after excluding the infection, patient responds very well to the steroid or immunosuppressives, possibly the disease that we are describing is an autoimmune disease. A temporal link between environmental trigger, autoantibody and the disease process, and a family history of autoimmune disease. This criteria we use again in encephalopathies and autoimmune encephalopathy. If there is a history of autoimmune disease, one can consider it as a possible autoimmune disease. So, that being the dilemma, that is the first question. That's why I wrote, the title that what I was trying to discuss is presence of autoantibodies. Is it always diagnostic? Is it always something which we have to work with, or we have to interpret carefully and cautiously? To avoid, to further put us into the confusions, the next concept that came is the description and the discovery of naturally occurring autoantibodies. Almost all the autoantibodies, pathogenic autoantibodies, we have a parallel natural occurring autoantibodies. But there is a big difference between the pathogenic autoantibodies and the natural occurring autoantibodies. Most of the natural occurring autoantibodies were described initially in the 65-75 by Graber, subsequently strengthened by various discoveries by set of scientists. Very clearly, they demonstrated there are more than 300 and odd natural occurring autoantibodies. So now you can understand the dilemma that we have. You have an autoantibody which is occurring naturally. You also have a pathogenic autoantibodies. Mere discovering or finding out an autoantibody in the serum doesn't put us into a right point to say that yes, the patient may have or patient have an autoimmune disease. So there are certain criteria which distinguishes natural autoantibodies from the pathogenic autoantibodies. Most of the natural autoantibodies are IgM. They are produced by B1 cell from what we call as germinal cell configuration. Germinal cell configuration, what it means is there is a code for the development of these autoantibodies, antibody repertoire. That coding already is there for them to generate these specific antibodies. What that means to us is the very concept that what I started with, the immune system is not tuned to develop an autoantibody is wrong. The conceptually autoantibody repertoire against the self-antigens are already present in the germ lines. So that means the immune system has a tendency to develop autoantibodies, and not just that, they are produced by B1 cells and they are just developed without even the T cell and other cell helps. They just generate and produced by the mere stimulation, even in the physiological. One of the major functions these cells, these natural autoantibody does is they clear debris. For example, when there is a cell goes for a lysis, released dsDNA, released cell proteins, histones, they are all picked up from the site of necrosis or site of the injuries, moved into the liver and other tissues where it gets picked up by the reticuloendothelial cells and cleared. They work more or less like a scavengers, and they are also found in a healthy human. I said very clearly, one of the scientists has demonstrated more than 300 autoantibodies naturally occurring. And of course, when they move or flip from an IgM to IgG or IgG1 or IgG4, which are pathogenic, the same natural autoantibody can become pathogenic. So that's what we call as tolerance breakdown that is responsible for the development of autoimmune disease. So then comes the two concepts, what we call as autoimmune phenomena and autoimmune disease. I think any scenarios which fits into those criteria are called autoimmune disease. When you have an autoantibody but not having disease, then we use a term called autoimmune phenomena. And of course, I didn't want to confuse you. There is one more called autoinflammatory syndromes where there is no autoantibodies, but I'm just sticking to the autoantibodies where you have an autoantibody, no disease, autoimmune phenomena. If it is IgM and doesn't have a pathogenic role, then you call naturally occurring autoantibodies. You have a disease which fits into the criteria, then you call autoimmune disease. So how does these autoantibodies produce the disease? So there is a breakdown in the tolerance. As it breaks down in the tolerance, they go and sit in the target tissues. In the target tissues, these autoantibodies generate inflammations. Once they trigger inflammation, there is a continued ongoing destruction of the tissue as a part and parcel of the inflammation that results in the disease. Just to give a simple example, in ANCA, the anti-neutrophil antibodies, especially on the peroxidase, with the resting neutrophils, usually peroxidase are not expressed on the cell surface. When they get activated, they get expressed on the tissue surface. They do secrete. The ANCA antibodies form an immune complex, causes lysis, causes inflammation, resulting in further tissue damage. It's not just that. If you come to the rheumatoid arthritis, I said in the very beginning that the rheumatoid factor, how does it produce the disease, we still are not sure. But when it comes to anti-citrullinated antibodies can attack citrullinated protein. Here, rheumatoid factor latis can enhance the activity of the anti-CCP, thereby stimulate the activations. Though IgM and rheumatoid factor can cause an immune complex, their persistent activation and persistent inflammation, how does it stimulate synoviocytes? How does it causes those actions are still uncertain. So there is no appropriate explanation how a rheumatoid factor, which otherwise we associate so strongly with rheumatoid arthritis, is responsible for the pathogenic process of rheumatoid arthritis. So we are in a dilemma where an autoantibody is there and we don't know how it produces a pathogenic process. And we also have a place where we have autoantibodies, we have everything to explain how that autoantibody can produce a pathogenic process. So that being the case, we are always confused how much importance I should attribute to a discovered autoantibody, how much importance I should attribute to an autoantibody which has been diagnosed and seen in a patient. So what is the relevance, how much importance or how much critically we should look into and view into this. In the next course of lectures, our different speakers are going to address on these crucial and critical issues, how, when, why we need to give an importance or a credibility to a discovered autoantibodies, and we will end up in few of the case scenarios where the autoantibodies were helpful, where autoantibodies misled us, with a debate where we can work on. So moving further, so as I said, the autoantibodies can function as both harmful and beneficial, and their fluctuating level is something which we cannot always explain. For example, you may have a very high titers of rheumatoid factor, patient may not have any symptom of rheumatoid arthritis, patient may have just around 100 international unit of rheumatoid factor, patient may have a severe rheumatoid arthritis damages. And rheumatoid factor, we keep on insisting to say that don't do the rheumatoid factor now and again, because the fluctuation in the titers of rheumatoid factor has no way connected and linked to the rheumatoid arthritis disease activity. There are few autoantibodies like dsDNA, etc., whose titers can match with the disease process and disease activity. So you have a group of autoantibodies where it matches, a group of autoantibodies which doesn't match with what the disease process is happening. Adding to that, advanced technologies have identified a large number of autoantibodies. The autoantibodies, when I started my clinical immunology training, was hardly around 50 to 100. Now we have more than 10K of autoantibodies. These are described, and around 1,000 plus of these autoantibodies has been shown to be pathogenic and cause several autoimmune diseases, starting from rheumatic diseases to sparing no organs of the body being affected by these autoimmune diseases. The challenges includes with reference to autoantibodies, is there variations in the course, whether I should give the credibility to it or not, and does it guide me how the principles of treatment can change and alter with it. And of course, current artificial intelligence, machine learning, and those tools are slowly going to be useful and helpful. These are going to be discussed in the due course of time. The overall, where we stand with reference to autoantibodies is, we now know it's a useful tool, and we are a little confused how much to use it, and when to give the due credence to it, when not to give the due credence to it, when I should ignore, when I should not ignore. And there are few issues and controversies which are still there with reference to the autoimmune disease and autoantibodies. I hope today's sessions is going to clarify few of the doubts, and few of the doubts which we are putting it across is still a doubt across the globe. It's not just for us, it's for everybody across. And so with this basic background, I think we will move on to the next few talks. I hope I have made the concepts clear to you at this point of time. Thank you very much for patience hearing.